Okay, guys, I wanted to do a quick video on what we've been doing the last couple of days. And this was one of the homework problems, or style of one of the homework problems that you guys had to work on. And so I just wanted to do a quick video in case you needed a little bit of extra help on kind of grasping this concept. And that was, if we were given a little bit of information, how do we find the degree measurement and the radian measurement based off of that information? And so what we were given was a trig function. And so we were working with sines, cosines, secants, cosecants, tangents, or cotangents, and it would give us a bit of information. So in this particular problem, we have the cosecant of theta is equal to 2 square root of 3 over 3. And then they also told us that the reference angle is 60 degrees. Now, the nice thing was that they told us what the reference angle was. We didn't need them to tell us the reference angle. We actually could have gathered that information just by them telling us that the cosecant of theta equals 2 square root of 3 over 3. But they told us the reference angle, which was, kind of nice of them to do. And so what they wanted us to do was they wanted us to find two pieces of information. They wanted us to find two angles that fit within this kind of range. They wanted it 0 degrees, which is less than or equal to theta, which is less than or equal to 360 degrees. And they also wanted to have two angles that were 0, which were less than or equal to theta, which was less than or equal to 2 pi. Okay, so they wanted it in degrees and they wanted it in radians. So I want to start with, how do we go about approaching this kind of problem? The first thing that we want to look at is we want to take a look at this bit of information. We're looking at the trig function that they gave us, which in this case was a cosecant. And we're looking at this side of it. I don't care what the value is, the 2 square root of 3 over 3. That really doesn't matter to me. All that I'm checking for is this positive or negative? Okay? That's all I really care about. I don't care what the number is. All I want to know is this positive or negative? Okay? I want to know what the trig function is, and I want to know, is this positive or is this negative? So if we go about and we draw out our coordinate plane, and again, you guys are dealing with my drawing skills, which are not the greatest in the world. We're dealing with the cosecant, right? And so we're dealing with, let me draw my coordinates in here, or my quadrants in here. We need to know the cosecant. Which trig function is that related to? So we have three trig functions that we use pretty regularly: sine, cosine, and tangent. And we need to know, is the cosecant related to which one of those? Well, we should know at this point that the cosecant is the inverse of the sine function. Okay, so that's the inverse of the sine function. You need to know that. Why do I need to know that? I need to know where the sine function fits in this coordinate plane. Okay, we need to know which quadrants that sine function is going to fit in. Specifically, when we're looking at this side of the graph, okay, when we're looking at the right side of this equation, we wanted to know, is it positive or negative? I don't see a negative sign, therefore this one happens to be positive. Okay, when we talked about our coordinate plane, I gave you this acronym, and it said all students take calculus, right? So all students take calculus. And that stood for all, sine, tangent, and cosine. And this gave us an idea of where the functions would be positive in those different quadrants. And so what this question is asking, that first part of it, what we're looking at is, which quadrants is the cosecant and the sine going to be positive? Well, we know in the first quadrant, everything is positive. So we know that the cosecant is going to be positive there. We also know in quadrant 2 that it's going to be positive, right? Cosecant is an inverse of the sine. Sine is positive there. Therefore, the cosecant is going to be positive. In the third quadrant, the tangent is positive. Okay, sine's not positive in the third quadrant, so we know that the cosecant's not going to be positive down there. And in the fourth quadrant, cosine is positive. That means that the sine and the cosecant is not going to be positive there either. Okay, so we know that we're working in quadrants 1 and 2. Okay, now we can kind of move on to the next bit of information that they gave us, which was that the reference angle is 60 degrees. Okay, what that means is that we can start to draw some triangles. We can draw a triangle. We know we're working in quadrant 1 and 2. We figured that out from the first bit of information. And so we can draw our triangles in those quadrants, okay? So I'm going to draw a triangle here, and I've got my reference angle that's 60 degrees. I'm going to draw another one here that is also 60 degrees, okay? Again, these triangles aren't to scale, but you get the general idea here. And so I want to start, I'm going to work off of just one of these, and I want to start working off of this one right here. I want to work off of the one in the first quadrant. The question is asking us for an angle of measurement that falls between 0 degrees and 360 degrees. And specifically, they're asking for something called the terminal angle. And this is an angle that starts on the x-axis and follows along the unit circle to that first coordinate point, okay? Now, the nice thing about the first quadrant is our terminal angle and our reference angle happen to be the same. So we know that the first point is going to be 60 degrees. That first degree measurement is going to be 60 degrees. Okay, so that leaves us trying to figure out what the second one's going to be. And again, we're starting at the x-axis. We're going all the way around the unit circle to this point. Now, there's some helpful information that we can use to figure this out. We know that half of a circle is 180 degrees, right? So if I went all the way around half a circle and ended up over here, that's 180 degrees. And we know that the distance from this half of the circle, let me try drawing this with green here, from the half of the circle here up to there, that's going to be 60 degrees, right? We have that reference angle that shows us that that's 60 degrees. And so if we take 180 degrees and we subtract 60 degrees from it, we should get the distance when we start all the way on the right up to our point. So 180 minus 60 is going to equal 120 degrees. And so now we found our 2 degree measurements, right? 60 degrees and 120 degrees. We're halfway there. We've got the 2 degree measurements. Now we got to find the 2 radian measurements. And now there are 2 ways that we can do this. We can take these degree measurements and we can plug them into our calculator, our formula, right? We had a formula that said we can take a degree measurement, and if we multiply it by pi over 180 degrees, we can get it in radian form. So that was one of the ways that we could solve it. But I suggest that there's actually an easier way of doing this, okay? And that is, if we go back and we think about the degree measurements that we have, 60 degrees is one of those measurements that we learned in radians. And it's one of those ones that we should know pretty regularly. There's 30 degrees, 45, and 60. Those come up an awful lot, and those are measurements that we should know. And so 60 degrees in radian form is going to be pi over 3, okay? So 60 degrees in radian form happens to be pi over 3. And again, because we happen to know that, we can just write that down, pi over 3. Now, the other measurement that we need to get is 120 degrees. Now, again, we can punch that into a calculator, and we can calculate that out, using that formula, 120 times pi over 180, and do it out that way. And that's a perfectly valid way of doing it, mathematically sound. There's another way of doing it, and it's if we think about the unit circle that we have, and this is a little bit more intuitive, but if we think about the unit circle we have, what do we know about it? Well, we know that this point on the unit circle is 0 or 2 pi, right? And we know that if we go to this point in the unit circle, that's just pi, right? That's half a circle, that's pi. So we can take the process that we use down here to figure out the degrees and apply that same process to the radians, right? We can just do pi, which is that 180, and we can subtract this reference angle, which we know, right? That's pi over 3. And that'll get us the measurement from this starting point all the way over to what we need to find. Well, I know fractions are a little bit scary, but this one actually isn't too bad. If we've got something and we want to make it a fraction, we just stick it over 1. We can't subtract these because they don't have the same denominator, but we want to make it the same denominator. So what I'm going to do is I'm going to multiply by 3, okay? Well, 3 times 1 happens to be 3, and what I do on the bottom, I got to do on the top. So I got 3 pi over 3. Now I'm going to subtract these out. Now 3 pi minus a pi. Now remember, we're not taking out just the pi, so I don't want to see this 3 over 3. That's not what happens, okay? What this is on the left side, I got 3 times a pi, and this is, if you want to think about it as 1 times a pi, that's perfectly valid. But this is 3 times a pi. So I got 3 times a pi, I'm taking one of those out, and I'm left with a 2 times a pi over 3. And that ends up being my other measurement. I got 2 pi over 3. And that are my 2 radian measurements. And so now I've got my 2 degree measurements, 60 degrees and 120, and my 2 radian measurements, pi over 3 and 2 pi over 3. And remember, radian measurements, they got to be left in this form. Don't punch it into a calculator and give me a decimal. That's not a radian measurement. It's got to have that pi over 3 or 2 pi over 3. Okay? And so this is the process that we go through when we're trying to figure out when they give us this information at the beginning and they want us to convert this into degree measurements or radian measurements to find those terminal angles.